All right, so today we will go through this lecture on lines and planes. So basically we will be covering attitude of lines and planes part, right? Have you gone through the lectures on topographic contours? If you have not, at least for today's lecture, it is not a prerequisite, but for the next lecture, please do go through them, because in the next lecture, we will combine lines and planes part with the topographic contours part. So we will study their outcrop patterns. So that is why it will be really important that you go through those lectures on contours. Let me show you where they are located on the course portal. Those who have not yet registered, please you can join our Telegram group. The link is given in the description. Let me share that with you again if you want. I can share that. But you'll find those lectures, they are all freely available. So in the course portal, I've released these lectures on topographic contours. So these contour patterns, topographic contour patterns. So please watch these video lectures. So it is basic. I think everything is given here. What is contour?
Hello
Contour
everyone.
patterns
So
of different
in
features
this
like
part,
valleys,
we will
hills,
understand how
basins.
to represent topography in geological maps. In this process, we will learn about contouring.
Just one second. This is coming from here. Okay. So geological maps, projections, topo sheets, rules of contouring. So all this part will be covered. Okay. So there are 6 lectures on this. Some are very short. So for example, I think this is few minutes, 16 minutes, 12 minutes, 16, 32,
exactly
44, and then 2
So
hours more.
I think
Okay.
most of you
Other than that. So it will take around 3 hours to cover all these, but you can spare 3 hours definitely in a day. So please go through these lectures. If you have not gone through these, let me share the link. If you don't know where the link is, so you can find it here. And you can message me on Telegram. So I hope all of you have joined the Telegram group. If not, please do let me know. Okay, so all right, let me put that YouTube as well. All right, so we'll start today's lecture now. And this lecture will also be uploaded in the course portal as previous lectures. All right, so lines and planes. So we'll study attitude of lines and planes. When we mean lines and planes, we are meaning structural features which are linear and planar. Okay, so we are not talking about topographic features here. We are talking about structural features here. We will study structural features, linear and planar structural features. In the last class, I explained to you what do you actually mean by structural feature. So you see an image here. So if I draw some lines, let's say you see these features. I'm drawing them in red colored lines. And then you also see other features. Let me use green color for that. Like that. So here, which is the structural feature? The one that you see in red lines or the one that you see in green line? Which of these is the structural feature? I explained that in the last
Red one.
The red line, right? Okay. So these are the structures. So structures are internal. So this is the, so what do the green lines represent?
Outcrop.
Outcrop, or basically the topography. The lectures that I've uploaded are about those topographic contours. How do you draw contours of topography? Please go through those. They are very, very important. Today we will cover the structure parts. In this image, what is seen is planar beds. In the next class, we will merge these two together. Or if this lecture takes 2 classes, then in the third class, we'll merge the 2 concepts. so that you will have structural contour. So you can draw contour for a structure, you can draw contour for topography. A contour, you know, is just a line joining points of equal elevation. So we will merge these two concepts of topography and structures so that you get outcrop patterns, you get maps of geological boundaries. That is where that rule of V also comes. Rule of V that you study is basically merging these two things together, what you see in topography and what you see in contours. So if someone, now this is a 3D image from the side. If you view from the top, you will see the topography, these green parts, and you will also see these red lines. So if, for example, here, if someone starts to draw topographic contours, they will appear something like this, V-shaped like that, because this is a valley. Okay, so this equal elevation will be something like this. If you start filling this with water, this is how it will appear. Okay, is this clear, everyone? Okay, so we'll cover basically points, lines, and planes. For planes, we'll study strike and dip. For lines, we will study three things: trend, plunge, rake, also called pitch. And then basically from practical perspective, these kind of questions are also very common in interview. How do you measure these things in the field? What is difference between clinometer and Brunton compasses? What is the concept of magnetic declination? And finally, this will be in the next class, or like these two will be in the next class. We will study the concept of apparent dip. Okay. What you are seeing here in this image, you do see some dip, but this is really apparent dip, and we will study that concept of apparent dip through practical examples. So first of all, we should define what is a point, what is a line, and what is a plane. A single point is defined by one set of coordinates x, y, and z in three-dimensional space using Cartesian coordinates. Okay, it is defined by distance and direction from a reference point. Reference point, for example, could be the origin. So if you are in three-dimensional space, okay, a single point, let's say you're defining this point, so it will be defined by its coordinates x, y, and z, which is basically you can take its projections onto different coordinate systems. So this will be the z coordinate, this will be the x coordinate, and that will be the y coordinate. Okay, so if this is x, y, z, like that. And then you have, it is defined, so if two lines intersect, you will get a plane, sorry, you will get a point. So two lines intersect, so if these are two lines, they are intersecting at a single point. Or it could be intersection of three planes. Okay, when you go to a line will be defined by two sets of coordinates. So if you have 2 points, for example, if you join 2 points, you will get a line. So if you have one point which is defined by x1, y1, z1, and another point x2, y2, z2, you can join them by a line. Like that. Okay, defined by 2 points, defined by distance from a reference point and direction of line. Okay, so again, if your reference point is origin, so if there is a line, let's say going like that, so what you can say is the line is pointing in that direction, and from the distance, what is the distance from the origin? You can draw a perpendicular from the origin and you get a distance from the point. Okay, two planes will intersect in a line. So for example, if you have this plane and this plane, so they will intersect in a line. Similarly, just moving the discussion ahead, a plane will be defined by three sets of coordinates x1, y1, z1, x2, y2, z2, and x3, y3, z3. It is defined by 3 points, defined by distance and direction from a reference point, just like a line, and defined by two intersecting or parallel lines. Okay, so simple concepts. but from geological perspective, we'll be starting the discussion now. The geological structural elements are usually a combination of typically planar and linear geometries. Can anyone give me example of any geological feature that is planar in nature? It's actually written on the slides itself. So some of the planar structural elements that you would see are bedding planes. Okay. So a bed is not a planar feature. A bed is a three-dimensional feature, but a bedding plane, that is basically either the top or the base of the bed or the intersection between two beds, are what we call the planar structural elements. Okay. Axial surfaces of folds, joint surfaces, fault surfaces, these are all examples of planar structural elements. What are examples of linear structural elements? Fold hinge lines, lineations, and slicken sides. So, for example, if you have a fold like this, the hinge line of a fold, it is a linear element. So hinge line of a fold is a linear element. Similarly, slicken sides. Do you know what slicken sides are? Does anyone know slicken sides? Those will be examples of linear structural element. So for example, if there is a fault plane and then there is movement along that fault plane, so you get these lines, so that is a linear element. Does anyone have a question? Prashant, I think you have raised your hand. Do you have a question? No? Okay. All right. So next comes the concept of what we call attitude. So what is definition of attitude? Now attitude, like individually, for planes you use the terms dip and strike. For lines you use trend and plunge. So what you're trying to do is, when defining these terms, you're trying to define the attitude. Okay. So attitude is kind of like umbrella term. So under attitude you have dip, strike. Under attitude you have trend and plunge. Those kind of things. Prasad, do you have a question? I think you have raised your hand again. What do you mean by attitude? So attitude is the orientation and inclination of a structural plane or line. It is a combination of bearing and inclination. So these are two important terms: bearing, inclination. All right. So what do you mean by these two terms, bearing and inclination? So what is bearing? So bearing is basically the angle measured between a line and a geographic coordinate direction measured in horizontal plane. Okay. So whether you are defining a line or a plane, so keep in mind these two terms, bearing, and the second will be inclination. It is the angle between a plane or a line and an imaginary horizontal line measured downward in a vertical plane. I will explain these with diagrams. Okay, so what you have to first of all imagine is, let's say if you're sitting on a table, okay, or you have a horizontal plane like this, so some horizontal plane like this. So the direction that you will measure with respect to, let's say, the north direction, okay, with respect to the north direction, that is called a bearing. So you have to start with horizontal plane. Start with a horizontal plane, and we are doing two things. We are doing bearing and inclination. Once you understand these terms, you will understand basically trend, plunge, pitch, rake, dip, strike, those things. For pitch and rake it is less important, but dip and strike, yes, it will be very important. What is bearing? So we'll go through what bearing is, but remember, bearing is measured in horizontal plane and inclination is measured in vertical plane. So if you have a horizontal plane, let's imagine this is a horizontal plane, kind of like you have on a table. Let's say this is a table. If you have anything on this table, let's say you have a pencil lying around like that, pointing in that direction, okay, and let's say this is the north direction. So bearing is nothing in this horizontal plane, it is this angle. This angle is called bearing. So you have to start, first of all, you have to have a horizontal plane for bearing. You have to have a horizontal plane for bearing. So there is a north direction, your pencil is pointing that way. So this angle with respect to the north is bearing. Now it doesn't have to be pencil, it can be anything. It could be an imaginary line, it could be an actual line. Instead of pencil, it could be a pen or a stick. That does not matter. Bearing is a general term. Okay, bearing is a general term. Those who have just joined, we're just defining two terms, bearing and inclination. Okay, so I explained that bearing is basically a direction measured in horizontal plane with respect to the north direction. Okay, so two things you have to keep in mind. It is measured with respect to the north and it is measured in horizontal plane. The second part is inclination. It will be measured in a vertical plane. Okay, it is measured in a vertical plane. So next part is inclination. Keep in mind it is measured in vertical plane. So just like you had that table, imagine you have a wall now. On that wall, let's say you have a watch or a clock, sorry, watch, you'll have it on your hand, and you have different hands of a watch. Let's say this is the short hand, this is the long hand. What is the time? I hope you can all tell the time. So what is the time in this image? It will not be exactly like that. Okay, so both are vertical, maybe one will have slightly higher angle. This would have moved a little bit to this side, but let's imagine they're like that. The hands are like that. Okay, so tell me, what is the inclination of the R hand? Who can tell me what is the inclination of R hand? Let's say the time is like this. What is the inclination of the hour hand and the minute hand, or actually both hands? So let me first define what inclination is. Inclination
0.
is, yes, it is.
Zero.
Is it 0 degrees?
Yes, sir.
Okay, so it could be 0 or it could be 90 degrees also, you could say. So angle between a plane or a line and an imaginary horizontal line measured downward in a vertical plane. So first you have to imagine a horizontal line here. So this is an imaginary horizontal line. Now you have to measure the angle with respect to that imaginary horizontal line. Now tell me, what is the angle? What is the inclination?
90 degree.
Yes, it will be 90. So inclination is angle with respect to horizontal, okay, measured in vertical plane. Whereas bearing, so you have to remember two things. It is with respect to horizontal, or either is it with respect to the north direction, and in which plane is it measured. So bearing is angle with respect to what?
Horizontal plane.
No, it is with respect to north. Okay, so what is the angle from the north direction? Like east will be 90 degrees of north, south will be 180 degrees of north, like that. So it is angle with respect to this north, measured in which plane?
Horizontal planes.
So you have to keep these two things in mind. So it is with respect to, bearing is with respect to north, whereas inclination is with respect to horizontal. Okay, if you don't understand, please do let me know, I will explain again. Bearing is with respect to north, it is measured in horizontal plane, whereas inclination is measured in vertical plane. You have to keep these two things in mind. In which plane is it measured and with respect to what? So when you have angle, you need two lines to define an angle, right? So you can define with one line, you cannot define angle. So that is why there is with respect to. Okay, so I'm not, in this case I did not ask, maybe you understood that I asked angle between those two hands. I didn't ask about the angle between the hands. What I was asked is, what is the inclination of the R hand? So this R hand has an inclination of 90 degrees. And of what is inclination of minute hand? It doesn't matter if it is up or down, it is still 90 degrees. In structural geology, everything in terms of inclination will be measured down. Okay, but when you talk about magnetic field, yeah, it can be up or down. Okay, so they have an inclination of 90 degrees. And why did I give example of table and a clock? What is the difference? Because a tabletop is horizontal, a clock is on the wall, so the wall is vertical, so the clock is also vertical. Now in this plane, it does not matter which is north south, because in a vertical plane you will do up and down, up down, those are the things you will measure. To measure direction, north south east west, you have to stay in a horizontal plane. That is why bearing is measured in a horizontal plane, whereas inclination is measured in a vertical plane. Is this clear, everyone?
Clear.
Are these two terms clear?
So, hello. Sorry, azimuth is similar to bearing.
Devashish, can you be a bit loud? I'm having trouble hearing
So
you.
azimuth is similar to bearing or not?
What is similar to bearing?
Azimuth.
Azimuth, yes. So
Yes.
azimuth is, you can think of azimuth, it is the value of the bearing. Okay, so it will be similar to bearing, so you can also call it azimuth. So azimuth and inclination. You are right. Okay.
Okay, sir.
So these are generic terms. Once you understand this, we will go through dip and strike. I will give you one homework because aptitude part is also part of GATE and mathematical concepts lecture is available for free. What I initially drew, let's say the time is what is the time here? Can anyone guess?
6:20.
Let's say the time is 6:20. Okay. So this is also practice of let's say your aptitude part. Okay. So we are trying to find out both the things. So this is homework for you. Find inclination of hour and minute hand. So this is like giving you practice of both geology and aptitude. Now this is homework. This will take some thinking, but now aptitude they are asking in ONGC exam also, GATE exam also. So you should keep thinking that way also. So what you have to do is find inclination of hour and minute hand in this case. Okay, I'll see like how many of you can get to that. And this is practice. It is okay to get wrong answers. You don't have to feel pressure that you have to get right answer right now. You have to get right answer 8-9 months down the lane during the exam time. So it is better to make mistakes right now. So find inclination of hour and minute hand in this case. Okay. Now this is important, what we're just covering now. One thing you will notice is that when you talk about hour and minute hands, in a house, you can actually have multiple walls. Let's say this is a room. Okay. And this room, this wall is east facing. So what will be that wall facing? What will be the direction of that wall?
West.
And what will be that direction and that direction? So that will be north wall. This wall will be south wall. So this wall that you see here is the south wall, south facing wall. Okay. Let's say you have a ceiling fan here. If it has 3 blades, what will be the angle between those? What will be the angle between each blade?
60 degree.
Are you sure?
120 degree.
120 degrees, right? So this blade is south facing. Okay. So for this fan, you tell me one thing. If I want to find the orientation of the blade, should I be defining inclination or azimuth? Or inclination or bearing?
Bearing.
Bearing.
Right? Why bearing?
Bearing.
Because it is in horizontal plane.
Okay. We are talking about horizontal plane. So I am interested in orientation of fan blades. So I should be defining the bearing or the azimuth. All right, so bearing is the angle with respect to the north direction. Okay, so it is always good that we are trying to view 3D from the side. Okay, so when you define those direction, north, south, east, west, like this, north, south, east, so what is the angle between north and east?
180.
Between north and east,
90.
90.
90
this
degrees.
is 90 degrees. So between north and south, it will be whole 180 degrees, right? So what is the bearing in this case? So you have to tell me bearing of the south facing blade. It will be, so you have to measure it from the
180.
north. It will be 180 degrees, right? So if you measure it from the north, so that is the north direction, that will be 180 degrees. All right, now tell me what is the bearing of this blade? This is 0 degrees. You found this was 120 degree and this is 180 degree. So just subtract 120 from 180, what will you get?
60.
60 degrees, right? So, or you could say like this whole angle is 120 degrees, so half of it will be 60 degrees. What will be the bearing of this blade? What will be the bearing of this other blade? Third blade?
60.
Are you sure? 60? So
300 degree.
basically you have the whole circle should be 360 degree. Okay. So either it will
So
be
70.
it will be 270 degrees. Either no, it will not even be 270 degrees. You have to add 120 degree to 180 degree. You see, this is 120 degree angle between each blade. You said angle is 120 degree. So add 120 degree to 180 degree. What will you get?
300.
Not 300.
300 degrees north. Okay. Or you can call it minus 60 degree also, because you are now going in counterclockwise direction like that. Okay. But don't say 60 degree. Either say minus 60 degree, or like the safest bet is to say 300 degrees. Because if you take another 60 degree, you will arrive at 0. 360 degree and 0 are basically the same thing. Is this understood? All right. Now let me make it a little bit more interesting. Let's say you also have a clock on this wall here. And what is the time? I don't know. So this is 12, this is 6. Let's draw the same situation as before when it is around 6:20. Okay, now the question I'm asking you is, I asked this previously also, so let's solve at least this part. For our hand, you can solve later. Okay, in this case, what is the inclination of our hand? Because it is 6:20. Okay, it is 6 to the time is 6:20. if it was 6:30, what will be the inclination of our hand? What will be the inclination? If minutes is 30, the inclination is 90 degrees. If inclination is 0 degrees, what are the number of minutes? In how many minutes will it be 0?
15 minutes.
15. That is a tricky part, right? It is not 0 minutes over here. So from 15 minutes to 30 minutes, it goes from 0 degrees to 90 degrees. Let me explain that over here. So this discussion is over now. When you have an R hand here, so let's say when it is pointing this way versus this way, so the inclination is with respect to horizontal. So this angle is 0 degrees here. So it has a 0 degree inclination and it has a 90 degree inclination here, because now this angle is 90 degree. And the minutes in each of these cases, it is 15 minutes and it is 30 minutes. So it covers, the hand covers, the minute hand covers 90 degrees in 15 minutes. But when you are talking about 20 minutes, okay, so the case that is given to us is somewhere here. So from 15 it goes to 20. So how many minutes it has to cover? 5 more minutes. So plus 5. So 15 plus 5 will give you 20. So to find angle, you have to focus on this part. That is why I'm saying like it is a good aptitude question as well. So you try to solve this for our hand, the original problem that I gave. This will be a hint for you how to solve it. So 15 plus 5 gives you 20. Okay. So minute hand covers 90 degree in 15 minutes. So in 5 minutes it will cover or like a better way of stating this problem. Let me add another page.
So 30 degrees.
Yes. How did you calculate that?
सर 15 डिवाइडेड बाय 5 तो 3 आता है, मतलब 3 पोर्शंस में उसको बांटना पड़ेगा, तो 90 डिग्री को 3 से डिवाइड करेंगे 30 आ जाएगा.
Correct. Okay. So in 15 minutes, it covers equals 90 degrees. So in 5 minutes, it covers 90 divided by 15 times 5, 30 degrees. Okay. So you have to add 30 degrees to it. Okay. So this angle now you have found will be 30 degrees. So what is the inclination? So the inclination of the minute hand at is equals to 30 degrees. Is this clear, everyone? If it is not clear, if you have any doubt, please ask. Let's go back to the original problem. Okay, so this is what we had over here. So what was the inclination of the clock? We found it out to be 30 degrees. Okay, it was simply this angle is the inclination part because it is measured with respect to horizontal and the clock is on a wall. A wall is vertical. So it is measured in the vertical plane but with respect to the horizontal. Do you understand these terms? So inclination is this. If I ask you this question now, what is its bearing? Can you answer that question? Can anyone answer that question?
$120.
120. How did you calculate bearing is 120 degree?
I calculated it from the north in a horizontal plane.
From the north in a horizontal plane. So how did you get 120 degrees?
Sir, from north to east it is 90 degree and 30 degree more.
This angle 30 degree, it is in which plane?
Vertical plane.
It is vertical plane. It is on this wall, right? Over here.
Okay.
Okay, so that 30 degree angle is this angle. Okay. So if it is in vertical plane, it has nothing to do with horizontal plane. Okay. So what is the first thing that you have to do? Yes, Saurabh, you got the right answer. So first thing you have to do is take its horizontal projection. So imagine if you're viewing from the top, or imagine there is light coming from underneath like that. There is a bulb or something. Where will its shadow fall? So its projection will be like this. So you have to take horizontal projection of that minute hand. So step number 1 is take horizontal projection of minute hand. And step 2 will be measure angle with respect to north. So you get both these things. You get it in horizontal plane. So your first task is to get it into horizontal plane. Okay. So, or you can just simply imagine rotating it back like this so that it becomes horizontal. Okay. So whether it is like this or like this or like that or like that, it doesn't matter. It will have same horizontal projection. Okay. So that is your first task once you take its horizontal projection. Now, in which direction is it pointing? In which direction is the horizontal? It is pointing in
East direction.
east direction. You are right. So what will be the bearing?
90 degree.
Okay, it is pointing in the east direction, so therefore it is 90 degree. If you were to take projection of the hour hand, it will point in west direction, and then it will be 270 degrees. Okay, so let's do now slightly even more complicated problem. Like in a house, we drew this situation. We had these different lines. You can have different walls as well, right? Let's say you have a clock here, you have a clock here. Okay, let's say these are, now you have clocks on these two walls. Time is 6:20, same as before. On this also it is 6:20. So in both these cases, what is the inclination? What is the inclination in this case? This is in a vertical plane.
सर 30 डिग्री होंगे दोनों में.
We had calculated it 30 degree. What will be the inclination for this clock? Or the minute hand? We are talking about the minute hand. Inclination here also is 30 degrees only. Okay, so in this case, you will take this as horizontal like that. So this is the horizontal. Okay, and that angle will be still 30 degrees with respect to horizontal. Both these are vertical planes. This is a vertical plane. This wall is vertical. This wall is vertical. If you look at all walls of your room, they are all vertical. But what is the difference between them? What will be the azimuth or the bearing in this case?
90.
We had already calculated it. It was 90 degree, assuming that is the north direction. What will be the bearing for this minute hand?
0 degree.
It will be 0 degree because you will take its horizontal projection that way, like that. That is a horizontal projection. Okay. So here the bearing is 0 degrees. Okay. So that is the difference between bearing and inclination. All the walls are vertical, means the inclination of the wall itself. Okay. We'll study that in dip strike part. So first important thing is to understand the difference between inclination and bearing. As homework, please do this exercise, repeat everything. Okay. As homework. So this is homework for you all. Find inclination and bearing for our hand for both these clocks. This is your homework. You have to find inclination and bearing for our hand for both these clocks. I hope you can do that. This will be a good exercise. As I said, it is both aptitude practice and geology practice at the same time. Okay. So you'll have to do some math like we did previously. One full circle is 1 hour, is 360 degree circle. Okay. So in 20 minutes, how much will it cover? That will give you inclination. But inclination here, you have to measure with respect to horizontal. It will be same in both cases. And then you have to find bearing. Okay. Bearing will also be slightly different. Any doubts, any questions? Too many pages added. Now we will go to geological terms, dip and strike. Okay, so we'll go to two terms, dip and strike. So the attitude of a plane, so when you're talking about plane, is generally measured in terms of strike and dip. You can think of strike as being equivalent to, so strike as being equivalent to what? So we studied these terms in the previous slides, previous notes.
Bearing.
It will be equivalent to bearing or azimuth. Whereas dip will be equivalent to the inclination part. So strike, if I ask you this question, just based on this fact that strike is the bearing, dip is the inclination, in which plane will you measure strike?
Horizontal plane.
In which plane will you measure dip?
Vertical plane.
Vertical plane. Strike will be with respect to
North.
and dip will be with respect to
Horizontal.
with respect to horizontal, yes. So it is measured, strike is measured in horizontal plane with respect to north. Dip is measured in vertical plane and with respect to horizontal or horizontal plane you can call. Okay. So what do we measure in strike? You say it is measured in horizontal plane with respect to north. Just like we were measuring the minute hand, the hour hand, you also have to say what are you measuring. Okay. So for strike, what we are measuring is just like a clock hand is a hand. A blade of a fan, we considered it as a line. So first step is you have to get a line somehow. Okay. For which you can measure strike. A plane itself, you cannot measure like where is the plane pointing. You can maybe, you have to somehow get a line from that. Sometimes we will try to draw a pole to the plane, but in this case to get the strike, the first step is to get a line. Okay. And how do you get a line?
By intersection of two planes.
And which will be the second plane? One is the given plane.
Second one is the horizontal plane.
Correct. Okay. To get bearing and azimuth, sorry, bearing and inclination. So in this case, it is strike and inclination. Which is the dip. First, we have to get lines from the plane. Okay. So those lines are the strike line and the dip line. Okay. So what is strike line? It is simply, very simply, the intersection of given plane with horizontal plane. This whole discussion will be easier when you talk about trend and plunge, because there we already have the lines. Whereas dip line, okay, so what will be the dip line? It is line in given plane perpendicular to strike line. So these are the two things that we have to get, and that is what is being done here. Is basically this is the horizontal line, which is simply intersection of horizontal plane and the given plane. So this is your given plane. Whereas this plane that you see here, let me color it maybe brown or orange. This is a vertical plane. All right, so first thing that you have to do is get this horizontal line by intersection of given plane and horizontal plane. Once you have the horizontal line, you get a strike line. And just as we defined the bearing, you measure the strike, the angle between the horizontal and the strike. Okay. So once you get the strike line, what is the strike? It is the angle between north and strike line. So this is the bearing. Dip line, what I said is, this is your given plane. Okay. This is your strike line. You already got that in step 1. Take 90-degree angle from the strike line inside this plane, inside the given plane. 90-degree angle, for example, this is also 90-degree angle from strike, like that. But that is not inside the given plane. That angle could also be 90 degrees. So if you measure, for example, with respect to this. So if you have two lines, if you have a line like this, let's say this is your strike line, this angle is 90 degree. This angle is also 90 degree. In fact, all these angles, unless you make it like this, but if you keep it like this, for example, pointing towards you, that is also 90-degree angle. Like that, that is 90, that is 90, all these are 90. So there are infinite number of 90-degree angles you can get between two lines. So it has to, you have to define which one. It is within this line. So this is the dip line, you can say. So now you have a line, it is easy to measure the inclination. I already explained. So inclination, for inclination, first you have to get a vertical plane. So which is this plane. And you have to measure it with respect to horizontal line. So you get both these two things. So you have a horizontal line and a vertical plane. This is what I said here. Dip is measured in vertical plane. So you need a vertical plane, which is this one, measured in vertical plane with respect to horizontal. So this is the horizontal. So this becomes your dip angle. Try to understand this part. Okay. If you have any doubts, please ask me. Okay. An analogy here is, for example, you have, let's say, these dipping beds, the actual structures or beds are exposed. Let's say the topographic surface and the bedding surface are the same in this case. And you have basically, let's say, water. Now water surface will try to stay horizontal due to gravity. So this line that you will get here, for example, that will be a strike line. Okay, that will be a strike line. And then you can measure its direction with respect to north. If, for example, north is that way, then strike becomes 90 degrees. You measure angle with respect to horizontal. So surface of water is horizontal. This angle becomes the dip, angle of dip. One thing to note, okay, very important. Maybe I can write it where I had this extra page over here. Dip and strike are defined for structures, not for topography. They are defined for structural features, not for topography. So for example, if you have a mountain, let's say Mount Everest has a slope, the surface is sloping down. Don't ask like what is the dip and strike of that surface. Okay, if Mount Everest has internal structural layering in it, for that you have to ask the dip and strike. Okay, so this is a student mistake many students commit, is for example in this very first image that we saw. Now this plane, this topographic surface roughly coincides with the bedding surfaces here, but this one does not. So there is slope here, you don't measure dip and strike over here. You will actually see this is a plane, maybe at some point this plane is exposed, a actual planar surface, the bedding surface is exposed. For that you will measure dip and strike. Don't measure dip and strike for topographic surfaces. Strike direction can either be specified between 0 to 90 degrees for each quadrant. Each quadrant means from north to east is one quadrant, from east to west is another, east to south is another quadrant, and south to west is another quadrant. So you can have 1, 2, 3 and 4 quadrants. So either you can say like 90 degrees, 0 to 90 degrees for each quadrant, or you can directly go from 0 to 360 degrees. It is your choice. So I'll say for example, in this direction, if your bearing is eastwards, okay, you can simply say the strike is 90 degrees. If it is pointing south, you can say strike is 180 degrees. If it is pointing west, you can say it is 270 degrees. Okay, like that. All right. So let's look at some of the examples that they have given here. So the dip strike symbol is usually this symbol, like this. So this longer line tells you about the strike, and this shorter lines tells you about the dip. Okay, and this number here, 90 degrees. So if it is written like 70 degrees, for example, this is the dip amount. Basically dip amount, or like what we just called dip in the previous case, or dip angle, is this angle. This is also called dip amount. Okay, so the number, when you see a symbol like this and written like 60 degree, so they will not specify this direction or this direction. You don't have to write strike direction or dip direction. You only, the number that you say is just the dip amount. Why do you think that is the case? Why do you think this is the case? In a map, let's say what you will have is, let's say you have a map of this region and there is a bed exposed like that. Let's say this is a bed outcrop. A map is always horizontal, and on a map, let's say a fold is exposed. You have a fold outcrop, And typically you will say dip and strike symbol for each of these limbs. So you will say like this, and maybe this one is dipping the other way. It's kind of like an antiform. And you will see, like, let's say numbers written here 60 degrees, 60 degrees. And this is a north arrow. So why do you only specify the dip amount? Strike is not written. Why do you think that is the case? Can anyone take a guess?
Because there is a 90-degree relationship between the direction and the strike.
But nothing is mentioned. Neither dip direction, neither strike direction. So there is dip amount, but dip direction will be 90 degree to strike direction. But dip amount is written. Okay, the reason is, okay, now try to think of this. This north arrow is already given to you. Okay, this north arrow is already given to you. A map will always have a north arrow. That is why you should always have a north arrow in map. Okay, so the strike direction can be determined by comparing to north arrow. Okay, and why can only strike be determined? Because map is horizontal. A map is always horizontal. So what is happening here is that you have this strike direction. So I am just taking a copy of this strike direction. I can just simply compare it with the north arrow here. Lot of time people would just want to know that it is striking northeast, southwest. You already know the strike is now northeast to southwest. And the dip direction, this is the dip direction. What is the dip direction in this case? It is southeast. Okay, so when you have this dip and strike symbol like that, the symbol will be like this. So it will be like something like this. Okay, so this line represents the strike line. Let me make it a little thinner. So this is the strike. This is the dip direction, so pointing that way. not the dip amount, but the direction. Dip direction is basically azimuth or bearing of that dip line. It is simply strike plus 90 degree. So this is the dip direction. And this number here is the dip amount. This is what this dip strike symbol means. Very important, because sometimes you may get question based on this. They will ask whether it is anticline, syncline, what it is. Okay. So this number that you'll see, it is just dip amount. Now dip amount you cannot determine here by comparing to north arrow or anything. Why? Because a map is a horizontal plane. And to measure dip amount, you need a vertical plane, which is not given to you. So it has to be spelled out. It has to be written what is the dip amount. But when it comes to the strike, sure, you can write like, yeah, strike is 45 degrees north. But that will make your map very cluttered. Why? Right? We have to give the minimum required information. Okay. So if you keep writing everything here, 45 degrees, 135 degrees, the map will become very cluttered. That is not needed. That is redundant information, because north arrow is given to you. Let me draw north arrow in different color here. So you can simply compare with north arrow and get the strike direction, dip direction, because strike is also measured in horizontal plane. A map is already horizontal. You can just measure the angle. But for dip amount, you cannot measure the angle, because dip has to be measured in a vertical plane. Is this clear, everyone? All right. So we'll go through plunge and rake in the next class. Try to digest what we have covered today. Okay, I will upload these lectures on the course portal. So please go and register for the course if you have not already done so. Revise these concepts from today. I want to maybe at the final stage want to cover this thing. So in terms of, let's say, the strike, I will write strike in green. So this is 45 degrees from the north. Maybe the strike is 45 degrees here. The strike is 90 degrees here. It is 135 degrees. And then you again add 45 degrees to it, you get 180 degrees. Okay. And then this is, if you add again 45 degrees to it, what will it become? It will become 225 degrees. It becomes 270 degrees and 315 degrees. So this is one way to represent strike. Another way to represent strike is, you can also say, for example, here north 90 degree east. Okay. Or you can say south 45 degrees west. That is another way to represent strike. Okay. So it is basically saying you go to south and then take 45 degrees from there. So south 45 degrees west. Similarly, north 90 degree east. This is another way. So you go north and you go east 90 degrees of that. Or you can also say, for example, this north 45 degree, north 45 degree east. Or you can say east 45 degrees south, like that. Okay. So you go east, take 45 degrees from there. So that is another way of representing strike direction. Now dip direction, there is another concept which is called dip direction also, because it is a direction. Okay. So this direction that you see here, it is also bearing. So it has to be measured in horizontal plane. Whenever the term direction comes, it has to be measured in horizontal plane. So this is the dip amount, this is the dip line. If you take horizontal projection of the dip line, you get what is called dip direction, which is basically 90 degree plus strike direction. So it is 90 degrees of strike. Okay, so we'll revise these concepts a little bit tomorrow. We will also solve the hour hand problem and then finish the rest of the part. It is very important that you understand these basic fundamentals because they will become very, very important in map interpretation. Lines will be easier. We have already covered that part. Okay. Any doubts, any questions? No? Okay. All right then. So we will stop this lecture for today and I will see you all in the next class. Okay.
हेलो सर।
Hello.
हेलो सर, ये पूछना था कि CSI और नेट के लिए उसके प्रिपरेशन के लिए फिर क्लाइमेटोलॉजी, ओशनोग्राफी क्या ऐड होंगे कोर्स में?
For this course right now, if you have seen the poll in the group, in the Telegram group also we did, in that there were 10% students who are interested in net. So our primary focus will be basically the geology part. So in net, of course, these concepts will help you in net also. But climatology, oceanography, we have planned that for some time. But the thing is like I'm not getting too much time to prepare for that. Okay. So we'll decide like if there is enough interest from students, if at least 4 or 5 students say like they want to study oceanography, then we can basically cover that subject also. Okay, but right now I cannot promise.
Okay, sir.
Okay. Any other question? Okay, if there no further question, then I will see you all in the next class. Bye everyone.